Welcome back to ECE 442-542. I hope you enjoyed your spring break, but I wanted to give you this on a special day, and so I'm calling this the Pi Day Lectures on the 14th of March, 3.14. And right now let's just try to bring us back from break and remind you of some of the announcements. Reading assignments are available in the course textbook, and that you can find in D2L on the resources module. But Chapter 3 deals with strategy number 2 on discrete equivalence. Again, Unit 4 is addressing discrete equivalence, and that's in the first few sections of Chapter 3. And strategy number 2 is really worrying about taking a continuous time plant or system, G of S, and consolidating with that the preceding D to A, which is our zero order hold, and the following A to D conversion process, wrapping those all up together to produce a discrete equivalent, and we're calling that our zero order hold equivalent. That's G of Z. You can contrast that actually with the other strategy, which is strategy number 1, and that's where we simply worry about the input-output behavior of this transfer function, which in our case typically will be a controller. It could be a filter, it might be a low-pass filter. In the analog setting, we're calling that capital C of S. And when we find the discrete equivalent, that we call C of Z. And we're doing a couple of different strategy number 1s. We're doing numerical integration, which we've done 3 different ways: forward, backward, and bilinear, or trapezoidal. And we're doing a pole zero matching. That material is in Chapter 6. You have additional lecture material to support Unit 4. Lecture 4.2 is dealing with zero order hold equivalence. That's strategy number 2. That's looking at it from this perspective. And in addition to that, or in lecture 4.2, I give a table of zero order hold equivalence, meaning that table actually incorporates the existence of a zero order hold preceding our transfer function. And I give an example of a zero order hold equivalent of an integrator. 4.3 lectures are dealing with state space representation. One is the derivation of the zero order hold equivalent. And the second, part B of lecture 4.3, is an example. And you can do this actually in MATLAB. If you have a state space representation in continuous time form, the A, the B, the C, the D matrix, then you can put that into a state space representation in MATLAB with the SS function. Then you place that representation of the continuous or analog system inside the argument for the C to D function, and that now converts it into a discrete time state space representation. Homework 4, which is the result of Unit 4, we've modified the due date for that. That's now on Monday, the 23rd of March. And just as a reminder, those additional lecture materials will help you work with some of the problems. Exam number 2, you're going to have to be somewhat flexible. That's not going to happen on the 25th of March. So stay tuned. There is review material for you to review for exam number 2 in the exam number 2 materials module on D2L. I will probably have a review session. That again will be asynchronously. You won't be attending any lecture for that, but you can submit questions for exam number 2 through the D2L quiz. There's also in that exam number 2 materials module a different transform table that might be helpful for exam number 2, because when we're dealing with zero order hold equivalence, a lot of times we will have the need to z-transform some g of s over s. If we now called that if we said, oh, let's just assume that this is now capital X of s, now we can immediately find what that's going to be in X of z from the appropriate row in this table. The table contains Laplace transformed waveforms, their analog waveform. Then what happens when you sample that analog waveform? You get this sequence of values representing a waveform, and if you z-transform that sequence, you obtain capital X of z. So this particular table in the exam number 2 materials module on D2L is useful once you can now identify capital X of s. That's right there. And now you can simply say, oh, let me find what that corresponding transform is in the z domain, and that's now what you would use for z-transforming this capital X of s. Let me erase some of that to remind the individuals in the graduate level section of this class, ECE 542, that your project is due, the first deliverable, and that's really just a statement of a sentence or two of what you propose to do on April 1. I'm not changing that date. And deliverables 2 and 3, which you will submit all of these deliverables into the appropriate assignments folder on D2L. Deliverables 2 and 3 is on May 6th, 2020.